It's great to be here, and wow, is that a tough presentation to follow? That was just, I think that those are the things that we all really, really strive to be a part of. So again, thank you. It's great to be here at Frontier Precision. For over 30 years, our focus is on customer sales, service, support, rentals, repair, and training. Uh, Whatever we can do to make certain your data collection uh, needs are successful across all geospatial platforms, from survey, mapping, scanning, mobile mapping. We are very, very proud to be Trimble's top geospatial dealer in the world. We're an employee-owned company of over 100 professionals with 12 retail locations, 8 repair centers, and 4 warehouses, all striving to make certain your guys' projects are successful. I am David Siddle. My father was a civil engineer. I grew up in the survey industry and joined the GIS world in 1995. I've been lucky enough to see tremendous advancements in GPS GNS, including standing outside on May 1st when select availability was turned off, to handheld devices, to current puck receivers, and to our topic today, which is mobile mapping. I absolutely believe that mobile mapping is the finest asset mapping tool and a true game changer uh, as it's going to affect mapping and surveying. From survey to construction, we strive to provide the best possible value for equipment. Plus, our team of applied geospatial engineers are here to help with setup, training, support. Again, whatever we can do to make you successful. I'm part of the mapping division. We're also an Esri Gold business partner with a team of support specialists dedicated to mapping workflows. Our support teams are available across 3 time zones. We have a water resources division, a division dedicated to mosquito control abatement, utilizing Esri-centric workflows. We have an amazing division of UAV professionals supporting multiple platforms, sensor, software, training, everything that anyone would need to start or grow a UAV program. Our scanning division is, which we're going to focus on today, I believe is a game changer for survey, mapping, and asset data collection. We've had several terrific presentations over the past 2 days on the technology. This presentation, we're going to focus on customer case studies, a little bit more in the specific of how they use the equipment and why they picked it. The MX7 components as a survey grade GNS, IMU, 4 360-degree cameras, 1 pointing straight up. One question we get often is, how much does it weigh? The best reference I've heard is it weighs about the same as 2 cases of beer. So there's absolutely no difficulty for one person to remove or mount it on a vehicle. Every image provides a 360-degree view. Any object that we can see, we can get the XYZ. From there, we can extract height, width, slope, plus we get the historical image of exactly what it looked like at that time and date. This image was collected in Fort Collins in honor of Mayor Truckle, who spoke yesterday. Quick overview on accuracy. At 10 feet, the horizontal accuracy is under 5 centimeters. At 30 feet, we're at 10 centimeters. At 100 feet, 15 centimeters. And at 240 feet, the vehicle, we are still under 30 centimeters. Using the extraction tool, we're measuring heights at 1 centimeter, even at 240 feet from the vehicle. It's my pleasure to introduce Josh Holmes with Dietsco. He's going to share their experience with Loveland Pulse Project. Josh, it's all yours.
Thank you, David. Hi, everyone. Thanks for having me. I'm Joshua Ohms with Ditesco Services. I want to give a quick overview. We are a project and construction management firm in northern Colorado, and our main purpose is to control risk and to manage construction projects from beginning to end with the clients. And so we have experience. We're involved in program management, in project selection. We we work on contract negotiations. We develop RFPs and specs and submittals. We have a pretty extensive engineering backbone, so we are involved in design of projects as well. And then we play resident engineer through the course of construction. So we are there, we are taking submittals, we are ensuring quality control and quality assurance goes on, and we are able to deliver a project from beginning to end. And part of the reason that we're going to able to provide this seamless delivery is that we are always looking forward. And because we have the full scope of the project in mind, we're able to see risks. So as we're designing, we're able to look forward and say, how is this being built? And what risks are involved in building this? And similarly, when we're in the field, because we designed it, we know this is what we need to be looking out for. So our projects our range is broad. We work in water, in wastewater. We've worked in transportation. We've worked for quasi-municipal districts, putting in raw water pipelines for many miles. And recently, we've gotten into the fiber broadband explosion that's happening in municipalities across the nation. So really, this is a wave that's going on right now where municipalities are providing broadband internet services to their citizens. And the Loveland Broadband Project is the first of these for us. And so really the Loveland Broadband Project is unique because of the scope, because of the geographical scope. It's kind of hard to overstate how we are working and placing conduit and underground enclosures and fiber cables and fiber equipment down every single street in the city of Loveland. We are giving an access point to this fiber network to every property in the city of Loveland. And so typically as we look to a project like this, we are looking at ways to minimize damage from the contractor to the owners. And in this project, we find that is exponentially more difficult because we're not just dealing with a single owner who has a large section of property, and so we need to make sure that damage doesn't occur outside the limited scope of the project. But here, the scope of the project is the entire city. So we are dealing with protecting the project from complaints that are erroneous, but we're also dealing with future customers. And so it's really, really critical that we are able to provide a quality and a seamless delivery to these customers when they come up and they say, hey, listen, we have an issue here. We need to be able to solve that issue for them in a way that leaves them with a positive regard to the project in general. David, can we move to that Loveland? Thank you. So again, the city's been divided into 200 individual sites. A site is about the size of a subdivision, and we're building the project in that way, site by site. And then we can move to the MX7. So one of the ways that Ditesco manages risk on any project is to take pre-construction photos. We go in, and the CSU Lagoon project that is wrapping up right now is a good example. I went and I took probably thousands of photos canvassing the exterior of the scope of the project and any internal pieces that remained that were untouched by the project. We tried to document that with pictures to show if during the course of the project the contractor damages something that previously wasn't damaged, that would be repaired. or if something wasn't previously damaged, that there's no question as to whose responsibility this is. And so this is really par for the course for us, that we try to document everything we can. With a project the size of an entire city, we are faced with a much more substantial workload in doing that. And so, I mean, if you live in a subdivision, think about the level of effort it would take to go through and take photos of every single sidewalk slab to either prove that there's no damage, or if there is damage, to show the extent of that damage prior to construction starting. And so we're looking at days of work for an individual and for a single one of our sites. And so across the project, we'd be looking at months, literally months of work, to spending field engineers and field interns going around taking photos. And what we end up with at the end is not as good of a product. We turned to the MX7, so David was good enough to introduce this to us. For a number of reasons, the key is that we can grab everything that we can see, and we just need to drive it. And so we get a better product out of it because we are able to grab everything. It's not a question of, okay, I get to the end of this and a homeowner calls in and says, hey, you busted up the sidewalk in front of my house. You need to come fix this. And now I'm having to sift through a file directory of photos and basically just scroll through to try and find where is this individual photo. And then if it exists, did it get exactly what I need to see here? And so we're going to look at a couple case studies here that show specific examples where the MX7 has already protected the project in a pretty large way from erroneous citizen claims. But importantly also, we are protecting future customers. So we're not able to be in the field with the contractor every second of every day, and we're not able to physically verify that damage didn't take place from them. And so we need to be able to protect customers from a contractor that causes damage and is claiming that he didn't. So this gives us a perfectly objective, there's no he said, she said involved. It's just, here's a photo. This shows the state of the existing conditions. And here now we can look at what is the current situation.
You know, Josh, I really like that for this project, you guys chose to rent the MX7. You want to touch on how you guys came to that decision?
Right. So because we're breaking the project up into 5 large areas, for this specific project, we were able to use a rental and plan that out to be 5 times throughout the course of the project. And it really worked for us from a cost perspective, rather than purchase the MX7 for this signal project. Right, so let's look at some case studies.
Yeah, the first claim, this is a boring that the claim was that boring cracked the brick wall. Tell us a little bit about this, and was there any type of ROI that was provided?
Right. So in this situation, the bore crews were set up actually down the road to the right, but potholing had already taken place behind this brick wall, and we were getting ready to set an enclosure there in the right of way. And the homeowner in this house we see came out to notify us that this crack in their wall was there, and to their knowledge it had not existed prior to construction coming by. And so we were able to bring up this MX7 data, take a look at the photo, and not only can we see that, yes, a crack exists, we can see that the wall's offset a bit, the crack is widened, it's clearly a structural crack, and it clearly was a structural crack prior to construction beginning in this area. And so the ROI, the response to that is that without this documentation, we would sort of necessarily, for the sake of customer satisfaction, be paying the contractor to go in and to repair this wall, they would need to, in this situation, they would need a specialty subcontractor because that's not something they do themselves in-house. And so we're involving other companies, we're exposing the project to a lot of risk. And so the ROI there, right off the bat, is the savings on this repair.
Perfect. So I love this claim. This was a crack in a driveway. In this photo, I can't even see the crack. When we zoom in, there's a crack, it's identified. Would something like this have been recorded in your normal SOP pre-construction collection?
We hope so. It's hard to say. And honestly, it depends on how thorough, if there's human error involved, potentially not. And so this is another good example. So boring was coming from the left to the right across the page, underneath the driveway here. And so I can look at that and I can say, it's likely that this crack, it's a transverse crack to the path of travel of the bore head. It's unlikely that this crack was caused by boring. If boring caused this crack, we'd be heaving and that crack would be going left and right. But right now, I'm saved having that conversation with a homeowner. I don't have to sit there and say, well, according to my opinion, it looks as though this crack couldn't possibly be caused by boring. I don't need to get into that at all. I have clear evidence here that the crack was there prior to construction starting. And you're absolutely right. A crack this small may not have made it into those initial photos. And so we're able to zoom in as far as we need to. We're able to have this monument database that shows us, here's the pre-construction conditions.
So we're using Trimble Trident. You want to touch a little bit on why you chose Trimble Trident for this workflow, the data extraction, and a little bit how that works?
Right, so we chose Trimble Trident because the volume of incidents like this coming in are not such that we need more than one person viewing this data at a time. And so the single user interface worked for this project. And it was really a scope consideration there. We didn't need to have something where as many people as we want can log on at the same time. I'm using this data to do some pre-construction design conformance work. And so I'm using it personally quite a lot. And then when we get complaints, the team generally is able to log in. But really, it was a volume question.
Perfect. And as renting this, you utilized our applied geospatial engineers. You sent the data to them. They did the pause back. They did so that you're able to just really focus on that extraction where you need it. Were there any other things that came up on Trident?
Not in particular that I can think of. Obviously it was a cost decision as well that we were able to use. It was more affordable for the project because of the limited scope there.
So this is one where the claim would be, heaped sidewalk. This clearly shows that it was a pre-existing condition. Just curious if the damage was a result of the boring, how would that affected your workflow? How would that tie it all together?
Right. So this would have been not fun to deal with. If this damage had been the result of boring, we can just visually look at that. Local standards call for no more than 1/4 inch of offset between slabs. And so there's been a good amount of differential settlement here. And just off this picture, I would say that we would need to be replacing at least 2, probably 3 of the sidewalk stones, and then basically the entire section of curb and gutter there. And so that work alone is, you have a day of demo, you have a day of setting forms, and you have a day of pouring concrete. You have to wait for it to cure. If it's cold out, you have to bring in blanketing. And so it's concrete work is costly. And this cost if we didn't have clear proof that this was not a construction damage, this cost would be felt by the project. And it would be felt by the project directly or indirectly. We would, if the contractor caused this damage, we would obviously be pushing back against them if they tried to change order us and say that the project needs to pay for this directly. But even if we're successful in those negotiations, we're now dealing with, every time we have undocumented damage like this come up, we are having to go into negotiations. We are losing good faith with our contractor, and they are now in a position where they are having to be more aggressive with us in order to get what they feel is fair. And so over the course of the project, obviously this individual situation is unfortunate, it's not the end of the world, but over the course of the project, that more contentious relationship would cost the project a lot of money.
And if this was to become a punch item list, you want to share a little bit on how you're utilizing, you guys own R2 Esri collector in your workflow if you had to go out and work on this as a punch item?
Right. So we are using the R2 along with collector to collect all of the as-built data for this project. And not only just as-built physically where the conduit was placed, but also we are using our collector app to track it's kind of a pre-punch. We do issue a formalized punch list elsewhere, but it's a live punch list. And so the contractor is able to, so in this example, we would place a point saying restoration needed here, or concrete repair needed. And we would be placing a point on each of the panels, and we would say, take out these panels, we can attach pictures to that. And the contractor has access to our collector, and so they are able to basically see as we go through the project and we investigate, we survey, and we inspect the finished work, they're able to see in real time what the results of our inspections are. And so they're able to go and fix issues prior to them entering a formal punch list situation. So that's been a huge help to us on the project with basically an R2 and the collector app.
So thank you, Josh. What were your biggest takeaways? And Josh will be available at the end of the presentation for questions.
Right, so for me, the MX7 was a real game changer specifically for this broadband project, but also elsewhere for us. On the broadband project, again, we're talking about literally months of work that we have saved by being able to rent the R2 for a week and drive it around. It gives us better quality. It removes the human error piece of this, and I don't know how we would be doing this project without it, frankly. Internally, we've considered proposing on this with other clients, as we do a lot of work with condition assessments. We do work, even engineering work, using the measurement functions that we have through Trident, and in that data itself, we're able to do we drive it once, we're able to do a lot of condition assessment work from the office, which is a lot more efficient, a lot more effective. And then of course, we're looking to move into future broadband initiatives, and this would be part and parcel to our proposal on those initiatives. This is what we're using. These are the hundreds of cases in which it's protected the project and it's protected the customers for Loveland.
Perfect. Thank you again, Josh.
Thank you very much.
So moving into another case study, All Traffic Data. All Traffic is a premier data collection services company from average daily traffic counts. So if you know the rubber hoses that you see across, that's them, to road condition inventories, to parking studies. Moving into mobile mapping, MX7 solution was a natural fit, and they own several MX7s. City and County of Denver, the transit stop and stationary inventory project, this was perfect for mobile mapping. with nearly 3,000 assets spread over the entire, city and county. One of the major benefits was a large amount of the data could be collected at one time and then extracted when there was time or a project would allow. This is a typical image of a bus stop, but there's so much data that can be collected. First off, we have the structure, we have location, condition, type, all of those pieces. We can bring in the sign data, light, trash can receptacle. We can even do a distance and slope to the ADA ramp. You can inspect the bus pad, and then way off in the distance is a very lonely Denver Broncos Mile High Stadium. The workflow that we worked with All Traffic is bringing in POSPAC data to Trimble Business Center, TBC, and then we export it into Mapillary. This was a very straightforward, simple process, and once it was brought in, it was very easily shared with the city. So this is just one project that All Traffic has. Do not hesitate to contact Dallin. If you have any questions, you can reach out to me. I'm happy to share. You can even book a one-on-one video with me. Moving into the MX9 mobile LiDAR plus imagery. Trimble has combined the best of all of the components. You have a Regal sensor, a Planix IMU, and Trimble GNSS. So they have combined all of these components to make absolutely the very best product. Key takeaway on this is that you can have up to 2 million points per second. Part of our services are to make certain that your back end is set up properly, that you have the horsepower, the speed. This is really, a significant change when we're dealing with data sets this large. Collecting data is only one part of the project. It's very important to us that you have all of the pieces to create a successful project. At no time will we ever say, here's your equipment, good luck. We're going to make certain that you have all the tools to be successful. Altig Engineering did an ultra-dense roadway data collection project prior to a wind farm moving in. This is very similar to what Loveland did, just on a much higher accuracy and density. It was both paved and dirt roads. It was the existing conditions. And this was really to confirm or deny damage and to expedite repairs when they were needed. This is Alaskan Pipeline project for BP. You can see the high pressure pipelines. The yellow line shows the edge of payment at an accuracy of 2 inches. If you can imagine drifts over 10 feet tall and how important that positional accuracy is for the snow throwing machines. It's absolutely crazy. But that was where that level of precision was absolutely required. The entire city of Toronto was an extremely accurate inventory for pole power and line inventory. This is a really fun project for road striping. Again, it is just the tip of the iceberg of what we can do with mobile LiDAR data. There are so many things that we can touch on. At Frontier, we're all about accuracy and repeatability. This is a page from one of our white papers showing vertical accuracy of the MX9 compared to 72 total station points. I think it's absolutely amazing that 100% of the checks fell within 0.2. I will share a link to our YouTube page on this white paper. Just a quick review, some key takeaways. Frontier, we have focused on customer service and support for over 30 years. Both Dietsco and All Traffic are absolutely tremendous resources for any of you. The MX7, in my opinion, is just the finest asset mapping tool on the market, and really and truly is a game changer. The MX9 is a future of scanning. Who knows what we're going to be able to do? This is a link to the YouTube page discussing that white paper. That white paper actually compares traditional survey with high accuracy GNSS, UAV LiDAR, and MX9 data. It is absolutely fascinating. Software, we touched on two different workflows. And again, this is dynamic. This is really ever changing from a single use desktop license to augmented reality, to AI extraction with Trimble eCognition. This data is ready-made for any of these applications. Again, all of these pieces tying together is what is really, really, really exciting. So with that, we can move into questions. Gavin, if there's anything we have, or Josh, if there's anything you'd like to share.
Okay, guys. Hey, thanks for the presentation. Like I had said earlier on in some of the presentations yesterday and today, seeing the real case studies is really important because, yeah, so many of the technologies we'd seen talked about for years and hypotheticals and, well, frankly, a lot of sales talk, but seeing the real case studies. That's been a big plus. I think you both did a good job of telling us about the equipment, but how the features were applied. We saw this yesterday as well. We've seen lots of mobile mapping systems, image-based image and scanning, aerial platforms, and even the handhelds and the backpacks. So, question I had for you, Joshua, one of the key things that you had tapped on that hadn't been talked about much in the last 2 days was this risk management, kind of covering your bases by having comprehensive imaging that, well, it's geospatially registered as well. So you're not flipping through images, you're going to a place and seeing the images from a couple of aspects and able to measure in it. So was that one of the key motivations for the image-based system, was risk management?
Absolutely. So it's both that we are completely canvassing the entire area where work is going to happen, and so we can manage risk there. But from a pure data management standpoint, our typical projects, we may have like a couple thousand of these photos, and so in a file directory, that's not fun, but it's workable. On a project this size, that's completely impossible. So okay. we needed something that is geo-referenced so that we can work with the data where we need it.
Okay, well, I remember files full of Polaroids taken by street address. So, gosh, I always have to put in the dinosaur quotient. Yeah, so David, about the MX7, that's your image-based mobile mapping system. So it's got the whole positioning package in it, like the Planix, and you process that with the GNSS and the inertial. But as for asset inventory, Joshua gave us great examples of the risk management pre-project photos, or photo archive. So you have customers doing. A question somebody had was what about the precision for the asset mapping? Yeah, I know you went over that, but we could bring that back up again.
Sure. So and this is really exciting on MX7 and asset mapping. That if you're within 10 feet of the vehicle for something very close, you have awareness of 5 centimeters. But if a lot of mapping accuracies are in that sub-foot environment, we can actually be out over 240 feet from the vehicle and still be in that sub-foot environment. So, the accuracy is going to be dictated by the project or the scope of work. But the real strength is in the extraction, heights, lengths, widths, and those are within 1 or 2 centimeters. We've seen with several presentations. But for the asset mapping, city and county of Denver on the other side of this is, the city was driven for the bus stop inventory, but now that same data set can be used to extract anything that's in those images. So a very, very powerful tool, very, cost effective. And that's what's getting people really excited. And you can drive it, once or twice a year with leaf on, leaf off, view, obstruction, all of these types of things. And what we get is that historical photo. We could actually, what did that look like at that date and time?
Okay. Another question. Well, somebody asked me what a Polaroid is. Okay, that's nice, Tom. It was back when we had clay tablets and we used to scratch in the map on it. Okay.
Yeah, I did mention being there when select availability turned off, and we went from 100 meters to 1 meter, and a coworker and I looked at each other and said, "Wow, what are we going to do for a living now?"
Yeah, that's true. Yeah, and I remember chasing 2 Doppler satellites. But anyhow, someone has asked if you could post that link from your presentation down in the chat box so they could get to it.
Happy to.
Okay. All right. So we've talked about the someone asked about you're gathering, Joshua, you've gathered all this image base. Can you or have you taken some of those images out of that image base, put them into another package to do, a lot tighter photogrammetry, perhaps like picking a known point to register it, because the absolute registration of the mobile mapping might not be the centimeter, but your relative could be incredibly tight. Is that possible, David?
So yes and no. Again, whether we're talking MX7, MX9, with the MX7, we're obviously going to be using real-time correction, and if the deliverable is in that 1 centimeter range, we're going to make sure that the equipment can do that, and that very well may be an MX9 project. So every conversation starts with what's your deliverable. What is the scope of work, or how do you get paid? And then we're going to work backwards onto what are the right pieces of equipment.
Okay. Well, mobile mapping can go from, how should we say, resource grade all the way up to, I was skeptical that engineering design grade, but as I mentioned yesterday, the project that I had talked to the team in Denmark, where the Danish government has now approved mobile mapping for railway corridor design work. They had gotten under a centimeter. It was a lot of control targets, but they are able to do it. So, Joshua, do you foresee you could be using the mobile mapping technologies on say, design, build, engineering grade type work at some point?
I absolutely think so. I think that's where we're heading for sure.
Okay. And David, could you got a few minutes left? Could you talk about some other types of projects people are doing with any of this equipment?
The MX7 has been my go-to for mobile mapping. A very classic one. Local city that wanted to do a sign inventory, and the asset manager called up and said, "Hey, I need to buy 4 geos and put 4 crews out to collect 20,000 signs." And through the discussion, it was very clear those signs will never get collected. It's impossible to have those crews in a timely manner to go out. And this is an ideal workflow for the MX7. You go out, collect the data, and you extract it. Depending on above ground utilities, we've had several people that utilize it for whole inventory audit, because again, the accuracy on the extraction, whether we're doing concatenary curves or any of the line attachment separation, those accuracies are perfect, and those can go right into design work. There are multitudes of city GIS that you know, if one city is driven, everybody from streets to water to storm sewer to asset to assessor's office, they can all use this same data. You know, I had one city that the assessor is traditionally not, you know, driven by technology, was very excited by being able to say, wow, you mean if I drive this once a year, we can look and then go to Mr. Citizen and say, gosh, you know, that barn has not been there for 5 years. And, you know, as Josh is pointing out, it takes the argument out. You know, it's a very clear, you know, this is where, you know, was here today. This was here, you know, a year ago. You know, it's really a lot of that, you know, comparative over time. We do a study with leaf on, leaf off. We've done cemetery inventories where you're into areas where you really do not want to have high impact. You know, it just goes, anything that we have that we're collecting assets now can be collected with an MX7. We've put them on golf carts. You know, so I think that one of the biggest ones in the engineering firm that, you know, Josh touched on, a lot of this is on pre-work or bid projects, where instead of sending, you know, an engineer or surveyor out for a pre-bid project, you can send a technician with the MX7 and drive the entire project. You know, I know that Josh used interns to drive this. You know, so instead of having him going out and taking thousands of photos of what he thinks important, you know, you can have an intern go out and drive. You get that single base layer, and that can very easily, you know, determine whether you want to do the bid or not. And if you do, that's your baseline. You know, from there you can do your takeoffs and add them to as-built layers. You know, the validation, verification aspects, those are absolutely critical. So again, anything that we've been doing with asset mapping before, absolutely, this has potential to be a fit.
Okay. I don't know why somebody sent me a question through an email, but there's a Q&A box, but anyhow, so this is about the, now we heard, you know, over the past 2 days, lots of great equipment, lots of great software, many different kinds. And the part about sort of being end user software agnostic, you've got, once you've processed, you've got exports for your clouds or and things like that to go off to people using like recap or context capture, things like that. Is that?
Absolutely. You know, and again, that's the first conversation starts with what's your deliverable? How are you going to be using the data? What is that workflow? You know, is it a CAD? Is it a design product? Is it going to a GIS? And then, you know, we'll make certain that the product and the workflow fits.
Okay. All right, gentlemen. Thanks for tag teaming on this one. The dealer and the customer. There you go. Awesome.
Thank you, Josh.
Thanks, gentlemen.
Thank you very much.